Hey everyone, it's Bob Crossen. I am the Vice President of Content Strategy for Endeavor Business Media's Water and Energy Groups, a division of Endeavor B2B. I'm here with Laurel Schaich. She is a Principal Environmental Engineer from CDM Smith. We're going to be talking about a microgrid project in Fort Wayne. So thanks so much for chatting with us today.
Yeah, happy to be here.
Yeah, so could you give me just a quick overview about this project in general? Like, how did this come about? Where did this microgrid come about for Fort Wayne?
Yeah, so Fort Wayne is a water utility in Indiana, and the client specifically operates both on the wastewater side and on the drinking water side. So they were seeing a lot of rising costs on their power bills, especially on their electricity costs. They were wanting to diversify their energy resources. So about 15 years ago, they started implementing backup diesel energy generation for really needed facilities that needed to operate in case of a black start operation or in case of a power outage. So they were looking to implement infrastructure that would help their resiliency and help diversify their energy generation sources. So the microgrid came about, and it allows Fort Wayne to electrically tie together three of their facilities: their drinking water plant, their wastewater plant, and their stormwater retention ponds, and also implement renewable energy generating resources such as a floating solar panel facility, as well as natural gas utilities and existing combined heat and power fueled by biogas. So those, paired with the existing electric utility connection, allowed Fort Wayne to create this microgrid with one utility connection and one microgrid controller that's kind of the brains of the facility. The microgrid controller is watching where power is being generated, where power is being used, and kind of turning systems off and on depending on the demand. And the program is allowing Fort Wayne to have multiple options for powering their facilities, using renewable energy resources when they're available. So when the sun is shining, they've got all of the floating solar available, and then supplemented at night when the sun sets.
Yeah. So you mentioned a couple of the benefits there. First of all, let me jump back on that. That's one of the most sophisticated energy plans that I think I've heard for a wastewater plant.
Yeah.
It's like they're certainly far ahead of the game. But when you mentioned some of the benefits there, are there some other things that they're witnessing through this program that they're like, wow, we're finding a lot of benefit that we didn't really anticipate initially?
Yeah, I think it really comes down to protecting their customers. They want to ensure that they can get good rates for their customers on their water and wastewater bills, and that they're not jacking up rates because of the high electricity costs. So Fort Wayne was seeing their energy prices rise about 7% per year, and wanted to do something about it. So they invested in this infrastructure, and they were really able to use existing assets and leverage facilities that they had on site, bring them together, and bring all of the electric generating facilities under one utility connection to help manage it and kind of diversify.
Yeah. So when it came to implementation, what were some of the challenges there? Were there things you had to overcome, and how did you overcome those particular elements? Yeah,
so we looked very closely in the study phase of the project. Before we even began design, we were looking at how much energy potential is there for these facilities. Like what's the right size of a solar field, for example. We were looking even at ground-mounted solar versus the floating solar, and we ended up choosing the floating solar because they had quite a bit of water availability for the panels to float on. But we did quite a bit of evaluation on how much energy have these three facilities been historically using. We looked at 15-minute interval data, so that's a lot of electricity data to look at, and we're really thankful that Fort Wayne had that information at their fingertips that they could provide us. So we overlaid that energy demand against what could potentially be generated from a solar array of varying sizes, and that looks at the geographical area and how much sun is actually going to be shining in that location at that time over the course of a year. And then supplemented by different energy resources such as natural gas generators, their existing combined heat and power, while maintaining a steady grid connection of about 1 megawatt hour. So all of that together, we were looking at different sizes, different utility connections, and ultimately landed on a 6.5 megawatt DC rated solar array, and then 3 megawatts of natural gas generation. Yeah. So, but that all took a pretty significant amount of time and pretty significant amount of data analysis. What's the cost benefit? What's the O&M cost of this? And we wanted to make sure we right-sized that solar. We weren't allowed to send any energy back to the grid, so we had to make sure that the solar was big enough that it could supplement the facilities, but not too big that we were over generating.
Yeah. Man, a lot of work has to go into that. I think about all the treatment side, but you add in this energy equation.
Yeah.
It's like just as complicated and just as complex.
Exactly. I mean, that they're doing this all while also still processing water and wastewater for their customers.
Exactly. At 3 different facilities.
Yeah.
Well, I guess the only other question I had, like I said, this is pretty complex. It's one of the more complex ones that I've heard so far in the water industry. When you think about like the horizon for this, if you look 5-10 years out, do you think that this will become more normal or more common?
I hope so. I think we're seeing a lot of water facilities and wastewater facilities look at their energy bills, and the bills are very confusing because you have your standard rate, and then sometimes you're charged an additional fee based on your maximum consumption over the course of a month, and that can really add up. So we're seeing a lot of our customers looking at how can we reduce our utility bills. Peak shaving is a term that's often used where you really want to trim off the maximum amount of power you're consuming over the course of a month. So I think our water industries are definitely looking for ways to diversify energy generation, look at ways that they can use existing facilities, look at renewable energy. We've got clients that have solar, that have wind, and supplement that with other facilities just to kind of level out their electric consumption costs and have the ability and diversification to have multiple options for operation.
Yeah, because outside of their operating costs or salaries, that's really the number one bill that they're paying every month.
Yes. So. Yeah, we need power. We need electricity to run the plants. I think especially with extreme weather events happening, that might cause power outages. So that puts the plant at risk. If it's a drinking water plant, then you have to issue a boil order. So making sure that there's resources available to diversify and to back up and have backups for your backup is really important.
Yeah. Awesome. Well, thank you so much for chatting with me. I appreciate it.
Thanks for having me.
And for everyone who's watching, you can check out our video description below for some more WEF Tech content in 2025.